Good day, everyone. My name is Graphics. If you look at the front of your screen, you will see a circuit that has 6 elements, which we know that the elements are the building block of the circuit. 5 of these elements are the passive elements. Why do we call them passive elements? Because of what? They consume much energy and distribute less. For example, we have the resistors here that has resistances of 6 ohm, 4 ohms, 3 ohms, 2 ohms, and 5 ohm respectively. And the other element, which is the active element, is the voltage source. We call them active because they do what? They only distribute energy in the circuit in terms of what? Of electric current. Now, in today's video, we are to use the Norton theorem in analyzing this circuit, where the 2 ohm will be investigated. So our point of focus and our point of reference is on the 2 ohm resistor. So that will be our RL. So the RL here is equal to what? 2 ohms, because we are investigating it. Whatever resistor we are investigating will be our RL. That is the load resistance. Remember, all resistances here are load. But since we are focusing on the 2 ohms, we'll call it our RL. Now that's by the way. Now this is the law. Before we can kick into business, before we can say you cannot withstand what you don't understand. Now let's understand what Norton theorem is telling us about. And the theorem states, it says any linear circuit and bilateral network can be simplified to an equivalent circuit consisting of a single current source and a parallel resistance that is connected to a load, where the single current source is the short circuit current and the single resistance is the Norton resistance looking inward, right? So with all this grammar that we see here, what is telling us is this. Look at the Norton equivalent circuits, right? It's telling us that the single current source is what? Is the short circuit current, we call it our I Norton, that gets to this node here, we call it, let's say, node B, and it splits into the current flowing to the RL, which we call the IL. And no matter how many the resistor is in the circuit, we'll take them into a single what? A single resistance, which is called what? The Norton resistance, which will be in parallel with what? With the load. That is the investigating resistor. So this is what it's just telling us, right? Now, if you look at this very well, we are told to look for IL, RN, and IN. To get the IL, we're going to apply our current law, our Kirchhoff current law. So how are we going to do that? Now look at this carefully. We're looking for IL, right? So IL will now be equals to, from this equivalent circuit here, Norton equivalent circuit, our IL will now be equals to the total current coming into this node, right? Let's say node B here. The total current coming to that node, which is our I Norton, multiplied by the resistance that the IL is not flowing through. Listen, multiplied by what? The resistance that the what? The IL is not flowing through. That is the current flowing through the load. Are you with me now? Is not flowing through. And what is the current not flowing through? It's not flowing through RN. So I'll multiply it by RN all over the addition of the two resistors. That is the Norton resistance and the what? The load resistance, which is the investigating load. So I'll term that by equation 1. Before we analyze this circuit first, I have to label this circuit. I'll number it or in an alphabetical manner to ensure or to enhance our understanding. So this point here will be point A, point B, point C, point D, E, F, G, and H, right? Now, let's kick into business. What we are seeing here, for we to calculate the IL, we need to know IN and RN. So let's start with RN, that is the Norton resistance. So calculating for the Norton resistance, right? I am going to remove the investigating resistor, which is our 2 ohms, right? Then I'm going to short circuit the 24 volt voltage source. And this is how my circuit will look like. Can you see that? So this will now be my terminal A and B. Now, if we current flow from this terminal here, let's call that current I1. And if you now flow to node C, what happened? It splits into 2. I2 is going towards the right and I3 is going towards the left. Now I3 will continue flowing through the 3 ohm resistor straight down to node B, where it splits further again into I4 and I5, right? So if you look at the right hand side here, we only have 5 ohm resistor, and that is the only resistor in the right hand side. So I'll call that the champion of the right hand side. But if you look at the left hand side, we have three different resistors at the left hand side, and we have the 6 ohm, the 3 ohm, and the 4 ohm. So we need a champion. So we have to apply our principle of summing up resistance in a circuit in order to get a champion here. Now, since we are looking for our arrow Norton, we can only use arrow Norton if we are bringing all the resistances together. But since we are taking it bit by bit, we're using arrow sub any given variable of your choice. You can use arrow A, arrow B, and so on and so forth. So now let's say arrow A. Now, since this is my focus, terminal AB, I will start moving from the left and from the right in this manner. So I will not focus on the right because I already have a champion. I'll be focusing from the left. So at the left hand side, we're coming from the back here. The 6 ohm is parallel to what? The 4 ohms. So that is what my RA is. And which means 6 times 4 over 6 plus 4. You multiply the 2 at the numerator and you add both of them at the denominator. So 6 times 4 is given to be what? It's given to be 24. Then 6 plus 4 is given to be what? 10. So 24 over 10 will give us what? 2.4 ohms. So my RA is 2.4 ohms. Now, if I now redraw my circuit, right? My 6 ohm and 4 ohm have become 1, which is my RA. So I'll write them out this way, 2.4 ohms. And we have this is how my circuit will be now. Right? The 3 ohm is still there, the 5 ohm is still there, and the RN is still there. Now, what do you notice? This I3 is flowing through the 3 ohm, gets to point B, still flows down because there's no way it can split, still flows down and pass through the 2.4 ohm resistor there, right? Which is at the rate of the 6 ohm and the 4 ohm in parallel. So because it's I3, the same current that is flowing through these two resistors, you see both of them are in series. So you represent them by saying RB is equals to what? 2.4 plus what? Plus 3. And that'll give us 5.4 ohms. So I'm going to now make here to only be just one single resistor. So that will give me what? My 5.4 ohm. Remember, I have made the 3 ohm and the 4 ohm to become 1 because they're in series. I added them together. So this is my ROB. Now we have a champion. ROB is my champion, which is the 5.4 ohms, right? So what we are going to do is I3 is flowing through. This is how my new resistor looks like, my new circuit look like. So I3 is flowing through 5.4 ohms. I2 is flowing through 5 ohms. Now, because two different currents are flowing through two different resistors, you see both of them are in parallel. So since that is the only resistors that is remaining in this circuit, I will now say my arrow Norton will now be equals to 5.4 parallel to 5. And that will give me, we multiply both of them, 5.4 times 5, all over the addition of both of them, 5.4 plus 5. So 5.4 times 5 all over 5.4 plus 5. And my arrow Norton will now give me 27 all over 10.4. Because 5.4 times 5 is 27 all over 5.4 plus 5 is 10.4. So if you divide both of them, you'll be having 2.60 ohms approximately. Are we together? If you are finding this video helpful, please don't forget to like the video. You click on the like button. Don't forget to subscribe to this channel, and don't also forget to share the video so that others can benefit from the video. Thank you. Now we've gotten our arrow Norton. Now the next thing, let me just put it here. Arrow Norton is equals to 2.60 ohms. So the next one is, if you look at our equation 1, we need to calculate for what? My I Norton. So calculating for my I Norton here, what will I do? I'm going to I'll go back to my parent circuit and I'll remove the 2 ohm resistor again. But what will I do this time? I'm going to short circuit it. So we'll call it I short circuit. So whatever current flows through this terminal AB will be called what? I short circuit, which is called what? Our I Norton. So I'll be using my I Norton here, which is also called the I short circuit. All together. Now, if you look at it closely, very well, we'll start again from the terminal. Current flows from the lower potential to the higher potential. Let's say the current is I1. I1 keep flowing through the 6 ohm and get to what? Node B, where it splits further into I2 and I3. I2 is the one flowing through 4 ohms, but I3 will continue flowing through the 3 ohms until it gets to node C, where what will happen? It will not split. Why will it not split? Because of what? Let's take for instance, the I3 will just flow only through terminal AB, the short circuit AB, but will not flow through the 5 ohm resistor. Why? The reason is this. Let me take you viewers as an example. If you are I3 and you are flowing, you get to a junction A, and the junction has 2 streets, right? One of the streets is leading to where you have 5 soldiers guiding, protecting, or will I put it, one of the streets has 5 armed robbers, 5 thieves, or will I say 5 armed robbers, right? Now, and the other street, AB, has no armed robber. What will you do? What will you now follow? Which street will you now follow? You will not go through the street that has 5 armed robbers. You will go through the street that has no armed robber. Are you with me now? So that is why the current I3, which is you will not go through the 5 ohm because you feel like it is more risky to go through the 5 ohm. But going through the short circuit here where there is nothing to obstruct me. So what I will now tell you in terms using an engineering term or a scientific term is this. Note this. current only flows through the path of what? Least resistance. Current flows more through the path of what? Least resistance. So where there's no much resistance, a lot of current tends to flow through that path. So that is the reason why the current I3 will not flow through the 5 ohm resistor, but neither it will not flow through the terminal AB, the short circuit here, because it finds it easier to flow through that path. So we have what? We have sidelined the 5 ohm resistor. We have boycott the 5 ohm resistor. So viewers, if you're finding this video helpful and entertaining, right, please don't forget to click on the like button on the screen, and don't forget to subscribe to this channel and also share this video. You viewers are the real deal. Thank you very much. So let's proceed. Now, because of that, we will now start. We want to now know the current that is now flowing through the terminal AB is our I3, which is the same thing since it's flowing through that part. So that means our I3 is equals to our I short circuit, which is equals to our I Norton. Is that taken now? So when we're talking about our I Norton in this case, is our I3. When we're talking about our I circuit, is what? Still our I3. So we'll move further. So what do you now notice? Since we are coming from the front here to calculate for the total resistance, how? So that means to get my I3 now, we'll use current divider rule. We're going to use what? Current divider rule. Now, what do you notice? I3 will now be equals to the total current, which is I1, multiplied by the resistor that I3 is not flowing through, right? So I3 is not flowing through the 4 ohms resistor, so I'll multiply it by that 4. Always remember that. Divided by the addition of the 2 resistor in particular. Right? What are the 2 resistor? The 2 resistor in parallel. So that is 4 ohm and 3 ohm. You are going to what? Add them together. I repeat, I3 that we are looking for is equals to the total current, the current that divided into I3 and I2, multiplied by the resistor I3 is not flowing through, which is the 4 ohms, because the 4 ohms is I2 that is flowing through it, all over the addition of the 2 resistor in parallel. So that's how we get our I3. That is what we call current divider rule. So I will term that my equation 2. Now that means for me to get my I3, I need to know what my I1 is. So to get my I1 will now be equals to what? The voltage source all over what? The R equivalent from your Ohm's law that says V is equals to what? IR. When you make the I the result of the formula, then we have V all over what? The R equivalent. So now we'll term that my equation 2. So when I get my I1 here, I will now put it into my equation 2 to get what? My I3. So this is my equation 3 here. So let's continue. Let's move. Now we already know my voltage in this circuit, which we know is 24. Right? Let me just put 24 there. But we don't know the R equivalent. So we need to calculate the R equivalent in this circuit in order to get my I1. So calculate for R equivalent here now. Since we are taking this resistor in bits, we're not taking them once, it is a taboo for you to say R equivalent. What you should do is to use something to represent whatever resistor you are taking. So I'll say my RA will now be equals to, we're coming from the back. Since our current I1 is in the front, so we calculate resistance from the back. So we say that my RA will now be equals to 3 parallel to 4, because those 2 resistors are in parallel. Remember, we have boycotted the 5 ohm resistor, right? So this means you multiply both of them divided by the addition of both of them. So 3 times 4 all over 3 plus 4 will give us 12 over 7. So my RA will now be equals to 1.71 ohms. Are we together now? So if I bring them, they are now form 1. They are now 1. So this is now what we have here. This is how it will now look like. Is that okay? Now, what do you notice? The 6 ohm and the RA, which is 1.71, are now in series. Because of what? It is I1 that is now flowing through that particular loop, right? I1 will flow through 6 ohm, I1 will freeze. So that is when I will now use my R equivalent, because that is the only two resistors that is remaining. So I'll see my R equivalent now give me 6 plus 1.71, and that will give us what? 7.71 ohms. Are we together? So from here, we've gotten my R equivalent. So I'll now substitute it into equation 3. So my equation 3 is telling me I is equals to what? 24 over R equivalent. So my I, that is my I1 now will now be equal to 24 all over 7.71. So my I1 is what? 3.11 ampere. Are we there? So we've gotten I1. Now substitute into equation 2. So my equation 2 is telling me I3 is equals to I1 times 4 all over 4 plus 3. So when I put in my I1 here, so my I3 will now give me, the I1 is what? 3.11 multiplied by 4 all over 4 plus 3, and that is 7. Are we together now? So my I3 will now give me, we have 12.44 divided by 7, because 3.11 times 4 will give us 12.44. So divided by 7, we have our I3 to be equal to 1.78 ampere. Now know that your I3 is your I Norton, and is also called what? Your I short circuit. So my I short circuit or my I Norton is what? 1.78 ampere. Are we there? So we've gotten our I Norton, and we've also gotten our RN. I will have our RL. So the next thing is what? Our IL. And remember, to get my IL, remember equation 1. So equation 1 here is saying that what? My IL, right, is equals to I Norton multiplied by R Norton all over R Norton plus RL, and we'll put in our values that we have. So my IL will now give me my R Norton, my I Norton is 1.78 multiplied by my R Norton, which is 2.60, divided by my R Norton plus my RL, which is 2.60 plus 2. So my IL will now give me 1.78 times 2.60 will give you 4.63, divided by 2.60 plus 2 give you 4.60, and when you divide these two, my IL will be equals to what? 1 ampere. Alright, so we've gotten all this. So my Norton equivalent circuit will now be something like this. So we have this current here, the total current, which is my I Norton, my I short circuit, right, which is flowing to this point B here, and it splits into IL. IL is the one flowing through the RL, right? So we know my IN to be 1.78, my RL to be 2 ohms, and my IL to be what? 1 ampere. Can you see? This is what our Norton equivalent circuit look like. So if you have found this video helpful, please don't forget to like the video, subscribe to the channel, and also share the video. Thanks for watching.